Welcome to this debrief video where we'll look at the 3 Section B questions in the 2025 December Performance Management Mock. I would generally allocate 54 minutes to the Section B, but there are 3 case studies, so that's about 18 minutes each. Anyone who's watched my Section B stuff before know I'm quite a fan of seeking out what I call the Section B outliers. Each Section B case study, the stem of the question if you like, then has 5 questions, but almost always there's at least one that doesn't rely on this information. They're generally a bit easier to get the marks and a bit quicker. So what I tend to do is look at the 5 questions, trying to identify those outliers, and I answer those first. Then I come back and I read the scenario, and I only then have to answer the remaining questions. The other reason for reading through first is it means when I come back to reading the stem of the question here, my brain is already searching for things that might help me get to the answer. So let's take a look through and we'll follow that process. Well, this is a calculation, so that definitely will rely on the information on the left. Non-calculations are generally a higher chance of being an outlier. This one indicate by clicking on the relevant boxes below whether each of the following statements is correct or incorrect if the learning rate for GHCO is 80%. Now, although this is about GHCO, this is very likely an outlier because it's given us all the information here. So with a learning rate of 80%, is it correct that the cumulative average labour time for 7 batches of output will be 80% of that for 6 batches of output? This is incorrect. An 80% learning rate occurs when we double the output, i.e. going from 6 batches to 12 batches, you double the output, then the cumulative average time will be 80% of the previous average time. So that one's incorrect. The same learning rate will continuously appear and be applied throughout all levels of cumulative output. That's not true. At some point in time, it's expected they'll reach the steady state where no more improvement can be made, and so therefore the learning rate will no longer apply. So that's one outlier. Which 2 of the following initiatives are not likely to lead to an increase in the learning curve effect? Again, this looks like an outlier to me. The management are exploring several measures to further improve labour efficiency, which 2 will not. Implementing a short-term employment contract for all staff, well, that's not going to improve the learning curve. The learning curve relies on a stable workforce. If you have short-term employment, you're more likely to have staff turnover. Providing on-site training to all newly recruited staff, training is one of the ways to improve the learning curve effect. Changing from a time-based remuneration to a piecework remuneration, that is likely to help because they're motivated to produce products, so that will help the learning curve. So it must be this one. Implementing a staff incentive scheme that's based on the balanced scorecard approach. So learning curve effect is about how quickly they can produce products, whereas the balanced scorecard looks at a wider range in performance, and therefore might actually distract from that focus on producing products. This is a calculation, so that's not an outlier. And this question, based on the current pricing approach, which of the following is most likely if a new order has a price quoted based on an estimated learning rate of 90%, but the actual learning rate is 82%. So this is an outlier. We're just being asked, what are the impacts of getting the learning rate estimate incorrect? So let's walk through the steps of what happens if instead of it being 90%, the learning rate is 82%. When they actually come to production, the improvement in the rate of production will be faster than they estimated. If it's faster than they estimated, that means they'll need fewer hours and therefore it's more profitable. So we can eliminate answers 2 and 4. However, they would have quoted based on the 90%, so that would be less competitive. So the correct answer is this one. So as you can see in this first Section B question, out of the 5 questions for GHCO, 3 were outliers. So I've now just got 2 which are linked to the narrative given on the left. So as with the Section A videos, if you pause now to read through this, and we'll do this implied learning rate to the nearest whole percentage calculation next. To work out the learning rate from a set of cumulative hours, we need to remember when we double batches, so we go from 1 to 2, or 2 to 4, and then 4 to 8, the cumulative time will reduce by a fixed percentage, and that percentage is the learning rate. I've set up a little table here. I've just copied this top two lines from here. So now the cumulative average per batch is the next line, which is 8 divided by 1 for this one, and 15.2 divided by 2 for the second batch, which is 7.6. So therefore the learning rate is 7.6 over 8, which is 0.95 or 95%. Although you wouldn't need to do this if we were to use 4 batches, that's 7.2. So 7.2 divided by 7.6 should in theory give us the same answer. A little bit of a rounding error, but it is still 95%. So 95% is our answer there. And then the other calculation was this question 19, and we're asked what's the price to be quoted per unit for the order of 150 units. So the costs are the direct materials of 150, the labour costs, which we've got 12 per hour, I'll come back to that, fixed overheads is 70, and then the markup is 25% on top of whatever's the total above. They come to 220. If I had 25% on, I'm probably not far off this anyway, so I can probably eliminate this. But now I need to work out what is my labour cost. This is probably the bit that most people found tricky. 150 units, and there's 30 in a batch, so we're making 5 batches. The average time is actually given to us as 35.50. So the total labour cost is $12 an hour times 35.50. That's for all units, then we divide that by 150. So our labour is actually 284. And we add in the 150 and the 70, we've got 504. And I multiply by 1.25 to include the markup, and I've got 630. And that's that section B question complete. On to the next section B question. We're looking at Leisure Co. Once again, I'll take the approach I took before, looking at the requirements before I read the STEM to identify firstly outliers, and secondly to prime myself ready to know what I'm searching for when I do come to read this. If Leisure Co aims to select the alternative that has the highest return under the worst case scenario, what should the room rate per night be? We're definitely going to need to reference the STEM there. If they apply min-max regret rule, what should the room rate per night be? We'll definitely need the information on the left, and we'll probably have to build a regret table. Which two of the following statements would justify use of expected value for Leisure Co's pricing decision? This is an outlier, probably because it's testing our knowledge of when the expected value is an appropriate decision-making tool. Leisure Co is exploring the use of EV in aiding its pricing decision. So we need to choose 2 of these. Firstly, when weather conditions are full of uncertainty. That's not when we use EV. For EV, we need to have events that are occurring again and again, and the probability of each outcome is known with certainty. When the decision maker is an optimist and a risk seeker, that's not the EV person. This is a maxi-max person. EV tend to be risk neutral. When the forecasted weather conditions have remained similar for the past decades, that goes back to what I said for the first one, that predictability and able to apply probability to each outcome. When likelihood of each weather condition is known with certainty, again, that one is true. What's the maximum amount that Leisure will be willing to pay for such information? That's a perfect information question, so that's very likely to need information on the left. Indicate by clicking on the boxes whether each of the statements regarding decision-making techniques under risk and uncertainty is correct or incorrect. This looks like an outlier to me. By applying appropriate tools and techniques, senior managers can eliminate risk and uncertainty in decision making. We can manage risk and uncertainty, but we can't eliminate it. When a decision tree is used to determine the optimal course of action based on ranges of uncertain information, it reflects the risk of a neutral attitude of the decision maker. That's correct. So decision tree uses expected values, which is a risk neutral decision making attitude. So in this section B, we've got 2 outliers. And once again, if you pause the video, have a read through, and then we'll start answering the other 3 questions in this one. The question is, if they're aiming to seek the highest return under the worst case scenario, what is the room rate per night? That's the maxi-min decision rule. And the way we do that is we work from the right to the left. So maxi-min, so we find the minimum, and the minimum is the worst outcome based on the decision they can make. The only decision they can make is how much they charge per room, which is these 3 lines here. They can't choose demand, they can't choose occupancy rate, they can't choose probability. Make sure when you are building a payoff table, you build it so the decision they make is sitting along the top here. And then the question we need to ask ourselves, if room rates were 100 per night, what's the worst possible outcome? And it's this one here, 236. If they were 200 a night, what's the worst outcome? It's 242. If they were 350 a night, what's the worst outcome? 223. And then, as I said, working from right to left on maxi-min, these are the minimums along the bottom, and then we choose the maximum of them, which is 242. Now don't put 242 in here. Again, they can't choose which of the outcomes occurs. All they can choose is the rate, and then the demand will decide which of these actually occurs. And the room rate we would choose therefore is $200 per night. If they applied minimax regret, what should the room rate be? Again, we work from right to left. We start with regret, build in a regret table, then we find the maximum, and then we find the minimum. So the regret table looks a bit like what we've got on the left. So I'm going to put the occupancy levels in. It's worth practicing building tables in the scratch pad because it's not very helpful the way it works. Because you can't tab, you have to use spaces and things like that. Keep it simple. Don't put too much in, like I'm not putting my $sign in or anything like that. And when we're building a regret table, what we do is we take each of the 4 things here, so super peak, high, moderate and low, and we identify which is the best of each of those. And the minimax regret rule is almost like an opportunity cost rule. So looking at super peak, the best outcome is this 1575, and in order to get that, we'd have to have chosen 350. Had it been the case that we'd chosen 350, then we'd have no regret because we'd have not missed out. So this becomes a 0, no regret here. And then we compare this 1575 to the other 2 outcomes. So had we chosen 200 and demand was super peak, this is our revenue, so our regret is the difference between this cell and this cell. And then similarly, if we're chosen 100, our regret is the difference between this cell and this cell. And then we have our first line of our regret here, with this being the biggest regret, this being no regret, and this being in the middle. And then we do the same for the next level. So if we had high demand, the best outcome would be this one on the right, and then we find the difference between that one, and then the difference between that one and that one. For moderate demand, the preference would be to have 200 a night because that gives us 621, so there'd be no regret had we chosen 200. So this time it's the difference between this one, and the difference between this one and this one. And then finally, with low demand, 242 is the highest, so that's our no regret position, and then we compare to the other 2. So this is our regret table. That's the first bit here. Now we need to find the maximum, and the maximum, I've probably confused you because I've used minus on some. Let's take that out. They're all negative or 0. So the maximum here, if we had chosen 100 as the rate, our maximum regret would be 873. Had we chosen 200, our maximum regret would be 473. Had we chosen 350, our maximum regret would be 59. And then we do the last step, which is minimizing the maximums. Well, this is the minimum out of the 3 I've highlighted, so 59, which means the room rate is, read from the top of the table, 350. In question 24, what's the maximum amount they should be willing to pay for such information? A private meteorological bureau claims to be able to provide an accurate weather forecast at least 1 year in advance, has approached them to provide such a service. How much should they pay? In terms of use of time, you might be better at guessing this one, particularly if you're running out of time on this question. There's quite a few steps to the calculations for finding what's called the value of perfect information. What we need to do is find the expected value without that information. Then we find the expected value with information, and the difference between the 2 is the maximum we'd be willing to pay. If you were running out of time and had to guess, I'd probably be guided a bit by this. You see, 714,000 is more than the revenue they would earn under 8 of the scenarios. So that's probably a bit high. The 291,000 is more than they'd earn under 3 of the scenarios. I think I'd be erring more towards one of the smaller values. Let's go through the actual steps and do the calculation. This is probably when it will pay off having practiced using the calculator, Because to find the expected value for the $100 night, we multiply the probability, the 0.1, by the 702, and then we add to that the 0.3 multiplied by the 476, we add to that the 0.35 multiplied by the 358, and we add to that the 0.25 multiplied by the 236. And then for the $200 night, we do the same for this column, and for the 350, we do the same for this column. You can be a bit more efficient than doing everything, and it's often worth trying to save a bit of time. And here's what I mean by that. If we look at every value for the $100 room, or every revenue for the $100 room, and we compare to the 200, in every case the 200 is higher. So if I multiply 0.1 by 702, 0.3 by that, 0.35 by that, and 0.25 by that, and then I compare with the 0.1 multiplied by the middle columns, the 0.3, 0.35, 0.25, the expected value here will definitely be higher than the expected value here. Mathematically, it's impossible for this to be higher. So I'm not going to do the $100 because it's a waste of my time. Because what I'm going to find is one expected value for each room rate, and the highest is the one we would choose. So we're not going to do the $100 just to save some time. Here, this is higher, this is higher, this is lower, and this is lower when we look at the 350 compared to the 200. And sometimes you can eliminate another one, but it depends on the probabilities. So let's say these probabilities were different. Let's say this was 0.5, this was 0.4, and this was 0.05, 0.05. Again, mathematically, I can see quite quickly that then this would be the highest EV. But because of the way that this is profiled, I'm not able to do that. So let's go ahead and do the 200 calculation. So you see, using brackets, I've put all of the 4 steps of the calculation in here, multiplying each probability by the revenue. So the expected value here is 63675. And now I just have to do the same, but for the 350. And this one is 68895. And as a decision rule, we would always choose the highest EV. So that means we would choose 350 a night because it gives 68895. Now we need to find the expected value, but with this information, this accurate information. Once again, I'm going to use a little table. I probably wouldn't do this in the exam, but this is just to demonstrate the steps. And you need to forget this process, I think, in order to engage with how this process works, because it's easy to confuse the two. They are both using probabilities, but in a different way. We've just seen how expected value works. But what would happen if we could have an accurate prediction? So if weather predicts demand, if we knew that the weather was such that we were going to get super peak, what would we do? We'd charge $350 a room because we get the highest amount. However, even though we can forecast it, we can't change it. So the likelihood of that occurring is 0.1. So over a year, 10% of the time, we would be charging this amount of money. Similarly, if we knew that the weather was such that demand would be high, which would we choose? We'd also charge $350 because that's given us the highest amount there. So our revenue would be $930, but because we can't control the weather, that would occur 30% of the time. When the forecast tells us to expect moderate demand, we're going to price at $200 a room. So that means our revenue is $621, and that will occur 35% of the time. And finally, when it tells us that demand is low, we're also going to charge $200 a night, and we're going to get $242. And following the same pattern, that will occur 25% of the time. So now my calculation is using the table I've created on the right. So 0.1 times 1575, 0.3 times the 930, 0.35 times the 621, and the 0.25 times 242. And that gives an expected value of 714.35. Remember, we're in thousands. That's that distractor. So that's how that got in there. Now the amount we are willing to pay is up to the difference between these. So we subtract the 688.95 is 25.40, which is that one there. That's the end of Leisure Co. Thanks for listening. On to FitCo, the third of the Section B questions. We can see instantly we've got a variance calculation, material mix variance, and total yield variance, and material usage variance. This one initially looks like an outlier, but I'm less keen because it's stating some facts. The total price variance is favourable. I'm not sure if it is. So I would leave this one and do this as part of the normal process. Whereas this one is more generic. I can see select whether each of the following statements is or are correct. Ideal standards are short-term targets and useful for day-to-day control of operations. Ideal standards are not achievable. So comparing performance against something that's not achievable means every variance would be adverse. It would demotivate and is not a good way to set targets or measure performance. Variance analysis is suitable in companies operating in a modern manufacturing environment. Variance analysis is more linked to traditional manufacturing processes. In modern manufacturing, you get a lot of customization, single orders, that sort of thing. So that is less likely to be correct. So we've only got one outlier in this question. It's very rare for there to be none. We did have 3 in one of them, so that's also quite rare. Okay, so we'll make a start on the variance calculations. But as with before, if you pause now, read through the information on the question stem. So in this question, we need to find the material mix variance. And in the next question, although it doesn't say, given the information, it must mean the material yield variance. Mix and yield variances are obviously part of a little group of material usage variance. And I would certainly recommend having a process, having a template that you can use and apply for mix and yield variances. And you'll see in the scratch pad I've put 26 and 27 together because there's an efficiency in working both together. I've also written flex. One of the areas where students get stuck is they forget to flex the budget. So remember, the cost card is based on one product. So we need to flex this based on actual production in order to make it a useful comparison. And this is what I do, is I look for what I call the actual quantity at the actual ratio. That's what actually happened. And I compare to the actual quantity at the standard ratio. Some people use the term mix instead of ratio. And the difference between those helps me get my mix variance. And the difference between the actual quantity at the standard ratio and the standard quantity at the standard ratio, that's the flexed budget, gives me my yield variance. I write this out more for the reasons of tuition, not for us to actually do in the exam. So this is the template I use for doing the mix variance. So I've got the 3 parts that are put in, the 3 ingredients, cereal, glucose, protein. Got a line for my total, and I'm looking to compare these two, the actual quantity at the actual ratio with the actual quantity at the standard ratio. And then we go hunting for the information. I start with actual quantity, actual ratio, and that's what we actually did. And that's the information given to us here. We've got 380, 127 and 100 in. And then when we total those up, we put 607 kilograms in total. And now what we need to do is take that 607 kilograms and work out what it would have looked like had we used the standard ratio, which is given to us here, where they put in 30 grams of this to 12 of this to 8 of this. And I put this here just for information. For every 30 grams or kilograms, we put in 12 of glucose, 8 of protein, and it totals 50. So in order to work out our column here, we take the 607, we divide by 50, and we multiply the result by 30, and then we do the same again multiplying by 12, and the same again multiplying by 8. So 12.14 multiplied by 30 means if we'd stuck to our standard ratio, would have used 364.2, and for G would have used 145.68, and for P would have used 97.12. And now we find the difference between this column and this column, and we need to be consistent. So I would do first column and subtract the second column. What's important in a mix variance is that the total of these should be 0, because we wouldn't expect any difference because we're just comparing the ratio of inputs, not the total input compared to the total output. We're still working in kilograms, so now we need to multiply by the cost per kilogram, which we take from our standard cost card. The variance is just simply multiplying those together. I've just rounded these through to bring them to one decimal place, just to be consistent. And the total variance is 56. Now in terms of is it adverse or favourable, I prefer to work it out. So we're looking at a material mix variance. The materials is an expenditure. So on this line, we actually used more than we expected to. So that would be adverse. In this line, we used less than we expected to, so that would be favourable. This one, we used more, that's adverse. Keeping the sign consistent, that would also be adverse. So 56 adverse is our answer here. And for my yield variance, I've copied and pasted this because I'm going to reuse some of it. So AQSR is reused, that's this one, but now we need SQSR. So I replace the first column with the standard quantity at the standard ratio. And this is where I flex my budget. I take the standard cost card where it uses 30 grams for 1 unit and we made 11,200. And then I need to divide that by 1,000 to bring it into kilograms, so I end up with 336. Next we use 12 grams of syrup. I'm just going to be efficient, multiply by 11.2 because then that divides by 1,000 as part of the process. That goes to 134.4, and then 8 lots of 11.2 is 89.6. So now we've got our actual quantity at our standard ratio of 607. Our standard at our standard is 560. So we used more than we expected to use because the actual compared to the standard. So therefore it has to be an adverse variance. If you're running out of time at this point, you could guess one of those two. Standard ratio we don't need for this calculation because we used it in the stage above to do this. So we next do the differences, subtracting one from the other. Of note, the difference is irrelevant here when we total it, because if it's adverse, they'll all be adverse. The costs are the same, so now I'm just multiplying that. I've already decided it's adverse, as I said earlier. So when we total those three together, we end up with 376 adverse. Key takeaways: make sure you have some sort of template for mix and yield variances that you can remember and you can produce quickly and efficiently, either in the scratch pad or in the spreadsheet if it's a section C question, and then use that to help go and find the information and pull it into here. The push approach, where you read through this and try and work out what do I need, tends to be harder to do and you're more likely to make a mistake. So template that you've tried and tested that you can reproduce in the exam, and don't forget to flex based on actual production. And for material variances, make sure you're using the standard cost per kilogram, not the actual cost per kilogram. What is the total adverse material usage variance? Well, if we add together our mix and yield variances, the 56 and the 376, that gives us 432. So we save a bit of time on that one. The other way to do it is to take the actual quantity and the actual ratio, subtract the standard quantity at the standard ratio, find the difference between those two, and then multiply by the cost per kilogram to get the variance. Okay, select whether the following statements is or are correct. The procurement manager performed well because the total price variance is favourable. Well, let's look at the price variance. The price per kilogram for cereal should have been 10 and was 11.2. For glucose should have been 6, was 6.5. For protein should have been 3.5, was 3.6. As all three are higher, then that means it isn't favourable, it's adverse. So that's incorrect. The mix variance indicates that the actual output was lower than expected despite the use of more premium ingredients. Mix variances are nothing to do with output, they're to do with the ratio of inputs. When we compare the ratio of inputs and our standard compared to what we actually did. For an adverse mix variance, you have more of a more expensive input and less of a less expensive input. So it's nothing to do with output, so that is also incorrect. And that's the end of this section B question. Thanks for listening.